Hello, everyone. This talk is part of Climate Match 2023 Computational Tools for Climate. I'm Angelo Arlotta and a volunteer here at Climate Match, and I'll be your host for this conversation on open science in climate with Professor Lubia Vinhas. Professor Vinhas is a senior scientist at INPE, the Brazilian Space Research Institute, where she's been working since the beginning of her career. She has a huge expertise in Earth observation, software development, and open science. Hello, Professor Vinhas. Thank you for accepting our invite first. So let's start with our questions. Can you tell us more about yourself and your research at INPE?
Sure. Hello, Angelo. Thank you for having me in this interview. My name is Lubia Vinhas, and I have a bachelor degree in computer science. I also have a doctorate degree in applied computing by INPE. Currently, I'm a senior researcher at INPE, where I started working in 1997. At the beginning, I was working as a software developer on various projects related to geoinformatics. Later, I was head of the Earth Observation Coordination of INPE, when I became more involved with remote sensing and environmental applications of Earth observation data, especially in the monitoring of land use and land cover that we do using satellite data. Currently, I'm still working on this topic, and I also lead a new project of INPE to enhance the management and use of geospatial data that we produce here at the Institute.
So you have been involved in many projects since the beginning of your career. Is there a project you would like to share with us?
Yes, I think that the project that I would like to share with you, it's of interest for not only Brazilians, but for everyone around the world, is the program for the monitoring of the Brazilian biomes using satellite data. This is a program that my institute is carrying on since 1997. At the beginning, we were making an annual inventory of the loss of original vegetation cover in the Brazilian Amazon only through the interpretation of remote sensing imagery, visual interpretation at first. The analysis was very much manual, with several experts delineating the deforestation polygons over an overlay of a printed image. Since then, in more or less 3 decades, we have only improved our methods, our tools, and the data that we provide. Nowadays, we are able to generate not only the annual inventory for all of the Brazilian biomes, we also generate daily alerts of deforestation and degradation that is used in controlling actions by other parties. And also in partnership with other institutions very important in Brazil, that's the Brazilian Agriculture Research Corporation in Brapa. We also generate biannual maps of land use and land cover, not only loss of the original vegetation, for the Amazonia and Cerrado biomes, which represent more or less almost 70% of the area of Brazil. And we are also now moving to use automated methods based on big data and artificial intelligence methods in order to continue the generation of this data more efficiently and timely, but with the same quality we have so far.
So we mentioned the Brazilian Biome Project and the Amazon. Why open science is important for the Earth observation and for monitoring deforestation in South America?
Yes. Well, I think that open data is at the core of this project. I would like to mention that in the last decade, we have experienced a deluge of Earth observation data available to be explored. My institution, INPE, was a pioneer in the open distribution of Earth observation data. In 2003, we opened the data of our satellite CBERS, China-Brazil Earth Observation Satellite, to be used without licensing or use restrictions. Later in 2018, the Americans opened the archives of the Landsat data, which is huge for all the world because it has a global coverage. And in 2013, the European Union also decided that the Sentinel mission, the Sentinel constellation, would provide open global coverage data, opened without restrictions of use. So Earth observation data is crucial for the monitoring of deforestation in the world's biggest rainforest. The Brazilian portion of the Amazon forest only has an area of almost 5 million square kilometers. Now we have the data, and we have to use the data in innovative ways. We need methods and tools to transform it into information to be used in policy making, and also to raise public awareness about climate change and environmental issues. Land use and land cover change, for example, in Brazil, is responsible for almost 70% of our emissions. So that's huge for us. In this context, open science is very important to create and distribute scientific knowledge, and also to increase the visibility of our results. Another issue that it's at the core of what we do at INPE is trust. We have to have open science, often open data, and open methods if we want to trust, to audit, and to reproduce the results that are so important that we are generating.
Okay, so now data are freely available, but are there some ethical implications of open science in climate, and in particular regarding deforestation issues?
Well, I think that there are always ethical questions to be considered in open science, regardless of the topic of the area of research. We have always to remember that we should not violate the privacy of uninformed individuals or leak and expose sensitive information that may harm individuals or even worse, entire communities, for example. In the case of deforestation in Brazil, the data produced by INPE is used to verify the compliance of farmers and companies in the meat chain, for example, or soy chain, for example, with the environmental laws in place in the country. But I don't see this as a problem or an implication, but rather as an advantage of having open science and open data, because it allows the third parties to do this verification of compliance, such as other organizations from the government or even from the public sector, the private sector, sorry. I believe that this separation of roles is positive and possible only through open science and open data.
So, like, open science can have a huge impact on the public. So, but is there a project or research you conducted or you are conducting that wouldn't be made without the help of the open science community?
Yes, I think that this project that I was talking about is one case. The opening of the Earth observation imagery repositories is a landmark in the area of big geospatial data handling. It made possible a whole new set of methods, algorithms, and platforms to explore these data sets. And these platforms, it thrives in the open science community's effort because people are sharing not only their data and results and publication, but also their programming, their algorithms in different programming languages. At EEP, we have been working with Earth observation data cubes, which is an emerging paradigm in the remote sensing realm, where large volumes of satellite imagery are preprocessed into a form that's more suitable for time series analysis, which the literature says that produces the best results working land use and land cover. And the Earth observation data cubes result in a continuous gridded data structure with at least the three dimensions, time, space, and the values. We have here at EEP a project called Brazil Data Cube, which we can share the website with you later, that it could not be made without the openness of the data from different providers, algorithms to generate analysis-ready data, and a stack of open source software to build a platform to organize and explore the data tree for Brazil. It can be used to research land use, land cover classification, fire, deforestation prediction, water quality monitoring, and many other areas. And this is the case that I think that would not be possible without the help of the open science community.
Oh, so the community behind the Brazil Data Cube project was very supportive and did a wonderful job. But like generally speaking, what's the biggest challenge you face as an open science ambassador?
Well, I think that we talk a lot about open science, but the term open science is not easily understood by everybody because it seems so huge and so difficult. Everything open, everything reproducible. But how? It's even more difficult to practice it. Yeah. So I think it's a challenge that we have to advertise practical examples in implementations of projects that are based on open science as a way to motivate researchers, but also to make it explicit the benefits of open science at the management level, because we need support for our management level to carry on this project in a sustainable way and for a long time. We need investments. We need that our institutions understand this, that being open and free, we are not losing anything. On the contrary, we are gaining a lot of things. But I consider, from my point of view, in my experience, that this is not easily, it's not easily to pass this message along in the entire institution and especially in the management.
So yeah, this concept of open science needs to be understood, but like how open science in climate can benefit the scientific community and also the public.
Well, in my experience, the things that comes to my mind, as I mentioned before, is the promotion of the knowledge distribution and trust building. I believe that it has the potential to make the scientific process more transparent, inclusive, and democratic. I believe that the scientific community is more and more aware of this, and how working with open data and open methods can also promote collaboration. A simple example is that when you have your science open, other groups can use and build on your results, generating new insights and new knowledge that will also be shared with you and everybody else. As for the public, I think that especially now when people are doubting science, open science can help to approximate the public's perception of science. For example, if we think about schools and young people interested in science, they can discuss and even practice some up-to-date science with fewer restrictions and fewer costs, for example.
Oh, we ended up talking about students and young people and talking about young researchers. What advice would you give to new students approaching open science?
I think that young researchers are much more open to approach open science, to use open science. If I would give an advice, would be to start open as default at the beginning. With this mindset, you start looking for open data, open source, open access to publications, open platforms, and then you see that most of you need and want for your researcher is already open. And then you will be inserted into this movement in a organic way, in a default way, right? Because you should start looking for open things before you decide that you need something that's not opened.
Oh, okay. Now we have one last questions. I think we're asking all our, to all of our speakers, and please share with us something any person watching us could use to support climate solutions.
I think that you should look for first the IPCC data and IPCC guidelines and publications and everything that the IPCC produces because it's open. You should look into um, in the remote sense community in this technology of data cubes because this is the future for working with remote sensing data. And you should uh, look and be aware of the data science perspective, right? That you should be able to, the students should be able to have some skills in programming, in climate, in data science methods and solution, because I think that this is where you're gonna find the better insights, big data, data science in general, and in the climate solutions, be aware of the work that's being done by the IPCC.
Thank you, Professor Vinhas, for being here with us today.
I hope that I said something useful for you, and thank you for the invitation.
Welcome. Have a nice day, everyone.